I'm Mahalya. Today I'm going to discuss about the continuation topic in atomic structure, which is Moyler's diagram, which is very important. Moyler's diagram or N plus L value for filling the electrons in orbitals or subshells which is in S, P, D and F. You have to follow this Moyler's diagram or this n value formula, n plus L value formula. Okay, first I explain this Moyler's diagram today. Okay, the distribution of electrons or filling of electrons based on this Moyler's diagram. Okay, you just observe carefully. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d and 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d. Okay, 7s, 7p and 8s. Okay, we just distribution of electrons through Moyler's diagram. It shows like this. We have to fill first energy level s orbital, later second level s orbital, later second level p orbital and then 3s, later okay. Next, like this we have to fill the electrons, okay, in orbitals. In first energy level, first 1s orbital you have to fill, later 2s orbital, later 2p and then 3s. Okay, later 3p and then 4s, not 3d. Okay, after 4s you have to fill 3d, 4p, 5s. Like this you have to distribute the electrons. This is the Moyler's diagram, which is important, or we can distribute the electrons by using the n plus L value. Okay, n means principal quantum number and L means azimuthal quantum number, which we just easily identify this. I take 4s and 3d. Okay, 4s and 3d. Just 4 means n value and s means L value. You have to observe clearly. Okay, 3 means n value and d is L value. I already said that principal quantum number is always in integer value, never ever zero or negative value. It's always more than one or more. Okay, Okay, here n value is 4. Okay, L value is, S means 0. Okay, here n value is 3 and D value, D, L means, okay, D means S E L 0, 0, that is S. 1 is P, L is 2, D, L is 3, that is F. According to this, you have to, D means 2. Okay, that is, you have to substitute that value here. Okay, just, okay, in this formula, n plus L value, n is 4, L value is 0, that is 4 here, and n plus value, that is, n value is 3 and L value is 2, that is 5. Okay, that means, so 4s having 4 and which is less than 3D, here 5. Okay, by this formula you can easily identify for these electrons. You have to fill from less to greater. Okay, less to greater, that means 1s, 2s, 2p, 3s, 3p, like that. Okay, here we have to fill first 4s, later 3d, because 4 here 4 and this is 5. Okay, you can easily remember this by these two methods. One is Moyle's diagram or n plus value. Okay, n plus L value. Okay, okay, next, for filling these electrons, there are some principles. There are 4 principles, which are, first one is Aufbau's principle, Aufbau principle. Second one is Hund's principle, Hund's principle. Third one is Pauli's exclusive principle, Pauli's exclusive principle. Fourth one is Heisenberg uncertainty principle, Heisenberg uncertainty principle. Okay, okay, these 4 principles I am going to discuss today. Okay, Aufbau principle. Here this principle says that electrons, we have to fill, electrons are also filled from low energy level to high energy level. Okay, low energy level to high energy level. That means atom, this is the nucleus. Okay, just draw here nucleus having protons, neutrons and electrons are outside the nucleus. The atom K, L, M, N shells and having 2, 8, 18, 32 electrons. Here S, SP, SPD, SPD and F. Okay, you have to fill the electrons from here to here, means low energy levels to high energy level. Okay, here you have to remember S having only 2 electrons, P having 3, which you have. Okay, Aufbauer principle explains the electrons which fill according to low energy level to high energy level. Okay, next, Hund's principle. Hund's principle, it explains the electron is subshell having equal subshell. Okay, if the orbital having equal subshells, that is, if here as having 2 electrons, then you can easily fill. Okay, if P, for example, P having 3 subshells and equal parts, and then you have to fill each shell with 1 electron. Later you have to pair that electrons. Okay, like that. It explained by Hund's principle. Okay, if equal subshells present to fill that electrons, then fill all shells with 1 electron, then pair them. Okay, for example, P, we have to fill 1 electron, later then you have to pair them. Okay, next, Pauli's exclusive principle. Pauli's exclusive principle. Here, these principles said that no. Okay, these principles said that no 2 electrons having same 4 quantum numbers. Okay, same 4 quantum numbers. Okay, here example, if take S orbital, here 2 electrons. For example, you have to divide here. Okay, here N is 1 1. Okay, L is 0 0, means SS. Okay, and M is 2L plus 1, 0 plus 1, that is 1 1 1. Okay, S is plus half and minus half, or half up or half down. Okay, like that. So he said that these principles said that no 2 electrons having same 4 quantum numbers equal, same 4 quantum numbers are not possible. Okay, next, Heisenberg uncertainty principle. Heisenberg uncertainty principle. Okay, uncertainty principle, and here position and momentum, that is mass and product of mass and velocity. Product of mass and velocity is the momentum, and is the momentum here, momentum and position. Okay, these two are not possible to measure at a time or same time. It is impossible to measure position and movement at the same time. Okay, this principle explains this. Okay, I just revising total atomic structure topics. Okay, now atomic models are four types. First one is Dalton's atomic model. Second one is Thomson's. Third one is Rutherford's. Fourth one is Bohr's atomic model. Fifth one is Sommerfield's atomic model. Okay, these are the 5 types of atomic models. Okay, here explained by Dalton, these by Thomson, these by Rutherford, and these by Niels Bohr, and these by Sommerfeld. Okay, he explained the atom is impossible to split into particles. He said that later it is wrong. Okay, Dalton explained atoms are impossible to split into particles. Okay, Dalton said that atoms are impossible to split into particles, and Thomson said that plum pudding model, and Rutherford said nucleus, and Bohr said hydrogen, which is electrons in stationary orbit only for hydrogen. He explained, and some important terms, which is a shell, subshell, and stationary orbits. Okay, all this, and primary particles, common particles, and primary particles divided into electrons, protons, and neutrons, and quantum numbers, and principles of electron filling, and Euler's diagram. All these topics in atomic structure. Okay, we have finished this atomic structure. Next we will continue with another topic. Okay, thank you.